Hi, welcome to this video on angle of elevation. Right, so we're going to be exploring 3 angle of elevations problem in this video. I'll have another video that explores angle of depression examples. Alright, so let's move into this. So the first question says, calculate the height of the kite from the ground. Alright, so the height of, so after a person raises a kite in the air, right? So for example, this, right? Let us look at this as the string of the kite, the string that is tied to the kite, right? This line right here. So you hoist the kite in the air, and then the breeze has it up there, and the string gets straight, so the string is not slack, right? So this is basically the string right here, and the point at which the string is attached, let us say the string is attached to something on the ground, right? So the string is directly attached to something on the ground, a piece of iron or a piece of board or something that keeps the kite from getting away. So after the person hoists the kite, they actually tie the string to a piece of iron or a piece of pipe or something that is on the ground to hold the kite. Alright, so this is the ground. So the point at which the kite is directly over the ground, right, would be this point right here, where the kite is directly over the ground. So the kite, so the line that connects the kite, not the string, the line over this side that connects the kite to the ground, we can say it's perpendicular, and perpendicular means 90 degrees, right? So perpendicular, right? Once you see perpendicular, you're talking about 90 degrees, right? So this forms a 90 degrees right here, and this point where the kite is directly over the ground to where the kite is tied to the iron or the piece of board on the ground is actually this length. And if you notice, you will see a right angle triangle coming out of this problem, right? And based on what we have covered before in trig ratio, I'm going to bring back a few things so you can see how we can apply them. So for the trig ratios, we have sine theta. Well, even before I go into the ratios, let me actually explore the mnemonics first. The mnemonic first. So S-O-H, so, ka, to. Right, so that was basically the mnemonic, where O stands for opposite, H stands for hypotenuse, A stands for adjacent here, and H stands for hypotenuse there, O for opposite and A for adjacent here. And if you look at this triangle, these names will actually come out. So this side is the opposite side. So please go back to the previous video on trig ratios and how to label the right triangle. So this side is the opposite side because it is opposite to the 40 degrees, right? And this side would be called the hypotenuse, HYP, because it's the longest side. And then this side down here, or the ground, is called the adjacent, ADJ. So please remember to go back for a basic recap on trig ratios, right? Because I explored that in heavy detail in the other video. Alright, so for this now, to find the height of the kite from the ground, which would be this point right here. What is this height of the kite, right, from the ground? So they are asking you to find this height, which would be, in this case, the opposite side. Right, based on what we covered in trig ratio, we're going to find out now how we can use trigonometric ratios to solve this problem, the height of the kite from the ground. So let's look at this. So we are given the hypotenuse and we are asked to find the opposite. So also find the opposite and we are given the hypotenuse. Now the trig ratio that links these two sides is the sine trig ratio, where we have sine theta equal opposite over hypotenuse, right? And after this it's just the basic substitution. So let's go now. So we have sine, remember theta is the angle, so in this case the angle is 40 degrees. So sine 40 degrees equal, what's our opposite side? We don't know that as yet. That's what we want to find. So we can use x to represent the opposite side, x over, what's our hypotenuse? Our hypotenuse is 6. Right, so our hypotenuse is 6. So let us now go a bit further. So to solve for x, we need to get x by itself. Let us isolate the x, which means we have to remove 6 from this side. So we multiply this by 6, right? And if we multiply one side by 6, we have to do the same thing to this side right here. So we multiply this by 6 as well. So on this side, these 6's will cancel. Alright, so we are now left with 6 times sine 40 degrees equal x. That can also be written as x equal 6 times sine 40, and that will give us the length of the opposite side, which will be the height of the kite from the ground. So let me plug that in my calculator now. So 6 times sine 40 sine 40. Alright, so the 6 times sine 40 gives us x equal 3.9 meters. Alright, so approximately 4 meters away from the ground. So the height of the kite is basically 3.9 meters from the ground, which is this side over here. So the height 3.9 meters from the ground. Alright, so as I said, please go back to the trig ratio video so that you can know how to use these with the various applications that I'll be giving. Let us look at the second question. What is the distance of the car from the building? Alright, so right here we have a car, a nice red car, and we have a school. Alright, nice big school right here. And at this portion of the school, you have 2 levels, this level and this level, but we are looking at this part right here, the lower level. So the height of the lower level of the school is 12 meters, right? This is not drawn to scale. 12 meters. And the angle of elevation from the car to the top of the school right here is 45 degrees. Right, so that's the angle of elevation, 45 degrees. So what this basically means is, if you should use your, like, a big nice protractor and put it right here, right, line it up nice, right, not drawn to scale either. So if you should use your protractor and measure this angle, well, for some questions it will be accurate, but as I said, this is not drawn to scale, so I won't explore the protractor concept here. But the 45 degrees is basically the angle at which you have to rise from this horizontal ground, right, to see it, to reach the top of the building, to be directly in line with the top of the building right here. So the angle of elevation is 45 degrees. The height of the building is 12 meters. So what is the distance of the car from the building? Right? So they need this distance right here. From this point of the building. Because if you notice, the line is right here, not drawn to scale. So let us check this out. So based on what we have covered in trig ratio, if you look at this diagram, remember, always look for your right angle triangle. So this will be a right angle right there. And the longest side is always known as the hypotenuse. The side that is opposite to the angle, which is this side in this case, is the opposite side. Use a different color. Is the opposite side, and then the remaining side is basically the adjacent. So if they want to find the distance of the car from the building, then they want to find the adjacent side. So we want to find the adjacent side, ADJ, and we are given the opposite side, which is 12 meter, right, for opposite. So the trig ratio that links these two sides is the tangent trig ratio, where tan theta equal opposite over adjacent. Alright, so let's carry out the substitution now. So tan theta is 45 degrees, so tan 45 is equal to the opposite, which is 12, over the adjacent, which is x. We want to find what x is. Alright, so in this case, how can we get x by itself here? Right, we have to carry out a few things. So we can remove x by multiplying this side by x and this side by x as well. The x's will cancel right there. Alright, so we are now left with, let me write this out explicitly, we are now left with x times tan 45 equal 12. Remember, we need to isolate the x. It's kind of done differently from the first one, so you have to pay close attention. Right, so how can we get this x by itself? If we divide both sides by tan 45, right, tan 45, these will cancel, and we are left with x equal 12 divided by tan 45. Right, so you have to carry out a few steps before you can reach some of these answers. Alright, so let's move on into this now. So x is equal to 12 over, so if you should plug tan 45 in your calculator, I think you would get 1, right? So tan 45 is equal to 1, right? So that means x is equal to 12 divided by 1, which is 12. Alright, so the distance of the car from the building is 12 meters. Right, 12 meters, similarly to the height. So the same height, the same measurement of the height, the same measurement of the top of this section of the building from the ground is 12 meters, and the distance of the car from the building is also 12 meters. Alright, so let us keep moving. Next question. Calculate the height of the ladder. Well, calculate the length of the ladder, sorry. Calculate the length of the ladder. So this is a ladder leaning on a tree. Right? Don't know what kind of tree it is. It could be a mango tree or something. So you want to get up here, you know, to pick some fruits for you and your friend. Alright, so that's basically the tree. And the distance of the foot of the ladder, as in the foot of the ladder right here, from the base of the tree is 10 meters. That's the distance. Right? 10 meters. And the angle of elevation that is formed between the ladder and the ground is 35 degrees. Alright? So it is now asking us to find the length of the ladder. Alright? So if you look at this problem, you will see that there is a right angle triangle coming out here, because we have this tall straight tree, have the ground, and we have the ladder. So if you can look carefully, it's a right angle triangle, right? If you look, you will see this diagram coming out of the problem. So this would be 10 meters, this would be 35 degrees, this side would be x. Right, so that's how you can do it. So you can look at the problem and then you make a sketch of how the triangle would look. So you are given, so this side, based on memory and labeling, so longest side is the hypotenuse, this side would be the opposite, right, and this side the adjacent. So you are given the adjacent, ADJ, and you're asked to find the hypotenuse, HYP. So which trig ratio links those two sides, right? Based on memory and what we have covered, it's a cosine ratio. So cos theta equal adjacent over hypotenuse. Alright, so let us do the substitution now. So cos theta is 35 degrees. Cos 35 equal, what's the adjacent side? 10 meters. 10 over, what's the hypotenuse? X. Because we don't know the hypotenuse, so that's what we want to find. X. So we need to get x by itself now. How can we do that? So similarly to the first problem, we multiply this side by x, multiply this side by x as well. These x's will cancel and we are left with x times cos 35 equal 10. Right? Still have a next step to go. In order to get x by itself, we divide by cos 35, and we have to do that to both sides. Cos 35. So these will cancel and we are left with x equal 10 divided by cos 35. Alright, so let us see what that is. So based on what we have been doing, you realize that there are certain steps that are associated to different problems. Alright, but if you pay attention to the video and to the different steps and how I drew the triangle from the problem, then you'll have a good chance of understanding. So 10 divided by cos 35 will give us 12.2 meters, which is the length of the ladder, right? So that's approximately 12. Let's put the 12.2 meters. So that is the length of the ladder, right? So those three problems basically covered the three basic trig ratios. I did that so you can learn how to apply all three in various questions. So thanks for watching this video, and please subscribe to the channel so that you can be notified of other upcoming videos. Thank you.